Dear students, welcome to the knowledge series. We are going to discuss on VxWork RTOS. This particular segment is also going to include the MicroC OS. And the whole discussion is a part of the continuations of the RTOS that we have discussed in the previous video series, and I believe that you might have gone through it. You know that today most of the devices in the network is found to be an intelligent devices. So they need to power an intelligence device so that everything can be carried out easily. But it's not an easy way to power such an intelligent device. So in that case, we have to see an alternate way. Thereby we can power the intelligent device to have a long run, as well as it can able to perform a maximum computation in an efficient manner. So here comes the VxWork real-time operating systems. Now if you look across the VxWork RTOS, it is coming under the class of a real-time operating systems, and it has been chosen by the global industry for the scalability, safety, security, virtualizations to meet the next generation's requirements. So for over 30 years, VxWork it has been working for creating an intelligent devices and that enable the IoT applications. So if you look across this particular side where it has been highlighted, the VxWork RTOS, this was developed as a proprietary software. Proprietary software means you have to purchase, it's not an open source software, and it was developed by Wind River Systems. This particular RTOS is a high performance Unix-like scalable RTOS and supports the ARM, Pentium, Intel Xscale and Super H, and also other processor for the embedded system designs. So if you look across the VxWork design, it is basically a hierarchical structure, and it is suitable for the hard real-time applications. Moreover, it supports the kernel mode of executions of task for a faster executions. So when you go for a kernel mode of executions, that type of execution is very fast for the application codes. And what is kernel? Kernel is the central part of the operating systems, or the nucleus of the operating systems. And there are many simulation tools that measures the performance analysis as well as debugs. Thereby this VxWork was developed, and that supports the various high-end applications, particularly embedded applications. The latest version of VxWork is 6.9, and this was the first commercial grade RTOS that supports the 32-bit as well as 64-bit Intel applications. So here you can see that there is a term that host and target based development approach. The host and target based development approach means the host is basically a machine, a PC, and whatever the target board is there, this particular host tries to compile and debug the code, and finally the target board, it is being downloaded for the real-time applications. So that's why it has been stated with respect to the host and target board applications. Moreover, you will find that the design structure or the development of this architecture, it's basically on the monolithic architecture, where you have studied monolithic architecture and the architecture. So under that particular segment, this architecture is being designed. And when we talk about embedded applications, you have to remember that it is having a software and also a hardware for the specific task. So that's why this type of VxWork try to support the various embedded system applications. Kernel mode, if you try to look for, in this case it is a microkernel, and it uses a C, C++ and Java based programming code to carry out the various activities. And here as you have seen that Unix, this is basically a process based systems, and VxWork is basically a task based systems. So this task based system, and this is a process based. So what is task? It is the executions of the programs. So that's how it carries the multiple tasking activities with respect to this VxWork RTOS. Now let's see some of the features. The first features it has been highlighted here is the multitasking using a standard POSIX scheduler. Now POSIX means a portable operating system interface. It is an IEEE standard for portable application facilities. So this multitasking, multiple task, that means a processor can do at a time, can perform various tasks. If you are gone through the various types of operating systems, there this multitasking has been discussed. So the multitasking environment uses this POSIX schedulers. So that I mean to say with respect to this particular portability can able to perform this particular multitasking. Now second point is that the operating system on a single processing layer. Now operating systems on a single processing layer means it has an it can able to do more than one activities. That means a concurrent activities can be carried out by the operating system using on a single processing layers. So concurrent activities means that means if suppose a single resource is there and that resource need to access by a two process. So under that particular conditions, so that process has to see that how that concurrency condition has to meet. So that is what I mean to say with respect to the concurrent behavior. The next point is that advanced multiple functionality. That means in the case of a multiple file systems, this advanced multimedia functionality can able to access the file facilities such as text, audio, image, or animations, or any other interactive applications. Those are the part of the multimedia. Synchronizations, full range of IPC options. That means it can able to perform a synchronizations on full range of a IPC. IPC means inter-process communications. So a connection between the various process, single multitasking or multiple tasking can be carried out using the IPC or inter-process communications. Different context for the task and ISR. The task and ISR means the ISR stands for integrated service routine. So that is nothing but the ISR stands for. Or we can say the interrupt service routing. So you can better instead of integrated, it is interrupt service routing we can say. So and the task can be with the various tasks. If it needs to be processed In that case, if ISR is there, the ISR will be given the highest priority as compared to the other tasks. So that is how different context switching can be taken place. Virtual input-output operations. In the virtual input-output operations, the pipes and the socket is been included. Pipes is for buffering. That means it does not have any packets, whereas in the case of a socket, the packetting communications is possible. So that is being carried out under this particular features. Moreover, the virtual memory management is also possible here. So virtual memory management is to communicate between the physical memory and the secondary memory. If the physical memory is having any shortage, it will be moved from the secondary memory. So that is how the virtual memory management function is being carried out. Power management, as you know, power management will try to enhance the ability of to control the power consumption. So like for example, a system standby or a computer power to turn off or to put the hard disk in the sleep mode. All these things is basically a part of the power management that is being employed in the VxWork. So these are the features that the VxWork is having. Moreover, interconnecting functions to enhance the or it to supports the large number of devices or large number of device protocols. So that is what with respect to the that is a layer or a nodes connections. Pipe drivers for the IPC basically for the inter-process communications. Network transparent sockets. Socket is basically I put it like a terms with respect to a bidirectional, whereas pipe is a unidirectional case in that case. So this socket is having a particular support in the case of a in this networking. So that's why this is a network transparent socket for the inter-system communications. Network driver for a memory and Ethernet. For the shared memory and Ethernet is basically for the LAN applications. A RAM device driver for the memory resident files. So RAM disk drivers for the memory file storage. And a processor abstraction layers. And a processor abstraction layer is basically it enables the application system designs. So abstraction layer actually it is a way to hide the implementations of the various functionality and as well as hardware, physical and logical device driver, so that it can be protected. So these are the some of the features that you can see under the VxWork: multitasking, single layer operations, multimedia operations, synchronizations, and task and inter-service routine. So like that, various virtual memory is there, followed by power management is there, and various device connectivities, as well as networks with having a socket facilities, as well as LAN facilities, and a memory device followed by abstraction layer. So that's how the VxWork future is being accounted. Now let's see the VxWork layer structures. When we talk about a VxWork layer structure, it is a real-time embedded applications, as you can see over here. Now, actually, when we talk about VxWork, if you look across the VxWork, it was initially a development and a network environment for VRTX. VRTX stands for Versatile Real-Time Executives. And later, these Wind River systems developed with the new microkernels. So that is how the VxWork architecture started building, find a new changes. But heart of a VxWork, if you look across, it is having a microkernels. That is a wind microkernel, and this microkernel, it supports the full range of a real-time features. So that is, you can see a various real-time embedded systems. If you want to run embedded application, you want to run, you have to have a graphics, multi-processing network. That's why internet should be there. Applications should be Java supported, and POXIX, as I told you, portable operating system interface facility should be available. File system. So and followed by the WinNet networking with the core OS of a microkernel. So this microkernel will thereby use these entire facilities, and that's how it supports the full range of real-time embedded applications, and where you can find multitasking, scheduling, intertask synchronizations, communication, memory management, like that. Various architecture supports it. It tries to extend. Now, if you go further, the VxWork architecture, here you can see this one is that hardware part is there. That is hardware independent software, hardware dependent software, and hardware. So this is the hardware part. Hardware dependent software is with respect to all the drivers, and hardware independent software is related to the various tool applications and various file systems with the Wind kernel as the main core part. So that is what we see. Now here, when you can see a BSP, it's a board support package. Basically, it provides the interface between the outside world and the kernel. So this is the kernel part is there, and it doesn't and it tries to initialize the hardware, clock, and the timer, and map the memory space and the memory size. So that is the role of this particular BSP. And at this particular section, interprocess management is being carried out. Kernel mode is there. So the central part and the RTOS is going to interact with the hardware using the supporting driver software. Thereby, the various applications oriented is being carried out using the VxWork RTOS. And moreover, you can see this in this one, it is a highly scalable, because it includes the various models, and moreover it can configure for even for a small embedded systems which has a tough memory constraint, and to a complex systems which has a more functions because of the inbuilt features. Furthermore, the individual models themselves is you can scale it. So that is what another point is that these individual functions, it can be removed from the library, or a specific kernel synchronizations can be carried out, so that these applications, even if you are able to omit if that particular application is not, it will reduce the size of the particular architecture, and that's how the compatibility can be enhanced. That is what we can see in this particular architecture. Now we go to another very important area, that is the task state diagram, or the task management. Now actually in the VxWork real-time kernel, it provides a multitasking environment, and VxWork supports even for the portable operating systems, that is the POSIX, and the proprietary scheduling mechanisms, that is the wind scheduling. You have seen here with respect to WindNet networking. So that wind scheduling can also support in this case of a task work. So to understand this particular task management, let's see this particular section. There are 4 different layers is been shown. One is suspended conditions, ready state, delayed state, and pended block. So the 4 state which you can see here. Now the suspended state is basically a ideal state. So just after the creation of or the state when the execution is inhibited. So from that means in this particular state already the execution which was suspended, that will be there, or it is from this particular state the execution is going to process, or that means it is considered as an input. Now the next state is a ready state. Now ready state, it is waiting for running. So that means a CPU can access the inputs, and that input as per the schedule or it is in the waiting based on the inter-process communication, the CPU will try to perform the ready actions. Pending is the task where the activity is being blocked, as in the case of if a particular message is waiting for the inter-process communications or from a resources, then this particular things need to be processed using a CPU in a later part. So whenever it is in a pending state, the CPU is not active here. But whenever the pending factor or the resources is recovering back, it goes back to this ready state, and the CPU try to process by seeing the schedules which is active as per the condition of that particular schedules flag. The CPU will try to process it. Another part is a delayed. Delayed is basically a part whenever the particular input-output operation is not taking place. It is being delayed for a certain time, or it is sent a certain sleep interval for or a sleep time interval is being carried out in the case of a delayed. Apart from this, the delayed and the suspended, if you are considering a delayed as well as suspended, then if it is not a preempted conditions during the delayed period, so we can consider that one as a delay or suspended. Preemptive means you can make the CPU to suspend the work and go to the highest priority task. So if the delayed and suspended, delayed followed by suspend is coming, and if it is not preempted, then during the delay period, then the systems will go into the suspend mode. So that is what we can try to see in the delayed and the suspend case. And another part is that suppose if it is a pended and if it is suspended, then that particular state is we consider under the block condition if it is not under the is not having a change. So delayed and suspended is needed with respect to the preempted state, and this one is needed with respect to the blocked state. So that's why there is all these things is a part of this particular task management. Moreover, if you are taking a pended, suspended, and a delayed period, then in that particular conditions, the task management will try to see that how this particular delay, suspended as well as pended can be a part of making the CPU to hold for a longer period or for a while. It all depend upon the complexity of the task, how it is going to process. So in the state diagram, as you can see, one part is a suspended or a ideal state after creations or the execution, that is one. Another is a ready state, where is active state, pending state where the task is not active and it is blocked. Another is a stop the particular task is been delayed. Third is a delayed and suspended when it is not in a preemptive states, and pended and suspended whenever it is in the blocked state. And the next case is the if you are going with the suspended case and the blocked case and the delayed case, under the interprocess communication, how that particular process has to put together, whether it has to be delayed or a suspended or a pended conditions, to see that the maximum performance or the utilizations of the CPU can be carried out in a proper task management concept. So these are nothing but a state diagram. The other area is a VxWork performance. So the VxWork performance, if you try to look across, it is having certain works like a real-time performance. When we talk about a real-time performance, it talks about demand time constraints, and the VxWork performance, whether it is a deterministic or it produces a good response, that is known as a real-time performance. Reliability, when we talk about reliability, we all know that RTOS is having a high reliable. So in that case, VxWork provide a better system performance, and it is having a security. It has having a strict security standards, and also try to see that it is error free. That is the performance of the VxWork. Scalable. So VxWork can able to provide a support for a 64-bit processings, and for a fast data supports, embedded real-time applications, and it can able to go for a small scale device as well as go for a large scale networking also. Interrupt latencies. Now in the case of interrupt service routing, so it is being considered as a high priority based on the number of tasks that is being employed, and the latency period in this case is 1.4 to 2.6 microsecond in the case of a interrupt latency. Next is priority inheritance. Priority inheritance mechanisms is basically exhibit for the optimal performance, and as you know that this inheritance mechanisms always tries to boost the performance of the RTOS. Footprint, it determines the memory capacity that is suitable for the RTOS, whether it is a RAM or a ROM. So that's how the VxWork configuration is being carried out based on the memory footprints. So these performance try to show a very best outcome for the VxWork. That's why we consider it as a high performance real-time operating systems. And one more point here is that if you talk about the interrupt ISR, this ISR has a high priority and can be preempted any time in the so that the task whichever is assigned to the systems can be diverted to the higher priority task. So thereby we can see that some of the applications of the VxWork. Now VxWork RTOS is widely used in the market for various applications because of its reliability and the safety critical applications. Today VxWork is basically focused in the military as well as civilian avionics, and you can see flight simulators, radio and optical telescopes, and when you talk about flight simulators, radio and telescopes, or in the helicopters, you can see Boeing 787, Airbuses also use this particular VxWorks. VxWork is also used in the navigation systems, deep sea instrumentation, traffic control systems. It is used for the even for the various safety applications. Even in the BMW driving car, this VxWork is being used. It is used for the modems, printer, digital camera, even for the Xerox phasers. It is being used. It has even VxWork is basically used for the space applications, for the spacecraft design, because of the low power consumption and the lack of access of the regular routine maintenance. This VxWork try to takes the place, and VxWork RTOS as an operating systems, it is used for the onboard computers systems, and you can see a router, switches and other networking systems it is being used. Even on the Mars explorations rovers, VxWork was installed, and that's how VxWork is also used for the various operating system in the that supports the industrial robots, or for the distributed control systems. Like that, in the multiple applications, the VxWorks application is find a place. Now we will talk about MicroC with respect to the discussions in the subsequent point of our discussion. So before conclusions with respect to the VxWork, let me put that one that in the real-time embedded applications there are various challenges with respect to the power, with respect to the expensive hardware. So such type of the constraint has given a way for the special design considerations for the development of the new RTOS that can able to have a robustness and efficient management with limited resources, and it can have a very good functionality, so that even in the critical conditions it will not able to fail and be secure and scalable, as well as very fast and robust, carrying out various multitask activities. So based on that, the VxWork RTOS find all these conditions, and that is being met, thereby it has occupied, or it has spread the wing into the wider applications as you can see over here. So the VxWork RTOS is the basic requirement in the current scenario. So with this I conclude about the VxWork. Let's see in the MicroOS. So MicroOS is basically, as you can see, it is the acronyms against the terms like a MicroC OS, and it is a real-time operating systems for a multi-task condition. And here also it is using a kernel for the microprocessor, and it supports the C programming language, and it is intended for the embedded C. So just like the VxWork, MicroC has its own system configurations. If you look across the features of the MicroC, it has a very small real-time kernel, and the memory footprint is about 20 KB. That is how the microkernel is being designed, and the source code it is being written using ANSI. So that is the features with respect to the MicroC, and it is highly portable, as you have seen in the VxWork. It is a ROM-based, very scalable, preemptive, real-time, deterministic, and multitasking kernels. Preemptive means I have talked about these particular terms in earlier, and it supports and manage in such a way that it can carry the 64 tasks. It can able to manage by the MicroC. Moreover, you can see that it has a connectivity with the GUI of MicroC and GUI of MicroC FS for the file systems, and it is ported to more than 100 microprocessor and microkernel. That is the point. You can see that how it can able to port, and it is simple to use and simple to implement, but very effective compared to the price and performance. So this RTOS is basically is designed for the real-time applications, and it supports the all type of a processor, whether it is a 8-bit, 32 bits or 64-bit. It supports. Now if you look across the task state, in the task state over here, I have what you can see. The task state is defined as 5 states. So operating system 2 is a multitasking operating system. Each task has an infinite loops and can be in any of the following 5 states: dormant, waiting, running, ready, and ISR. Dormant, actually this particular state procedures resides on a RAM or ROM, and is not a task. It is not a task unless an operating system creates a task, or if a user create a operating system task and thereby to execute it, then only this dormant will perform that particular activities. Here in this case you don't do any particular coding with respect to any task. Another point is a ready state. Here a task is neither delayed nor waiting for any event to occur. Once the task is created, it is in the ready state. Now running state ready. Now once this is ready, a ready task is scheduled to run by the CPU. So here the CPU is running, and there must be only one running task at a time, and task running might be preempted and become ready. So that is what happens in the case of a running state. And here comes the waiting. A task in the waiting for certain events to occurs. So so here in this case the timer will be there. So the timer expirations will be there, or the semaphore signaling will be there. So that is what you can see in this way. Now here in ISR is the interrupt condition if the task is normally interrupted by the ISRs. So a stack of the interrupt task is utilized in the case of a ISR. So you can see that under this condition the waiting, running, ready and ISR is a normal start, except the case of a dormant. So where no task correspond to the code, rather it is the user oriented operating system task create command it has to execute. So that's how the waiting to running is taking place, waiting to dormant is being taking suspended, and once it is ready it can be either put under the waiting state also, or running to ready state is the dormant can be put under the running state also. So that's how, because every state has to rely on the synchronizations. That is one of the important factor, and particularly in the case of a dormant, this particular procedure resides in the RAM and ROM for executing executions a particular task based on the user's executions command. Now another case is the task management. If you look across the task management, in this particular case, you can see the first is a task futures. So task futures, where the MicroC and the operating system can manage up to a 64 task, and the 4 higher priority task is there, and the 4 lower priority task in this particular case is there. And where if you are having if you can see the lower value of a priority and higher priority of a task, these are used under the case of a task management. The next is a task creations. Now the various tasks can be created in the case of the task management, which we have seen in the case with respect to the dormant conditions. Now the task stack and the task scheduling, that is the no, task stack and the task and the stack checking. So that's the another task management condition. You can delete the task, that is possible. You can change the priority of the task based on the whether you are going with the task with the ISR or based on the priority of the task. You can suspend and resume the task and get the information from the task. So these are nothing but the activities of the task management. Now here it has been put that MicroC OS manages 64 tasks, 4 higher priority and 4 lower priority tasks, and the lower priority task lower value of the priority and the higher value of the priority of the task. It's just like a monotonic scheduling follows, and the task priority number also serves as a task identifier. And this is what we talked with respect to the rate monotonic scheduling. A rate monotonic scheduling is a task with a higher rate of executions. So that is wherever you are going with the ISR situations, you prefer the higher priorities. And here assumption is that all tasks are periodic. Tasks do not synchronize with one another or share the resource, because all the tasks are independent, or that is the assumption is being carried, and it is a preemptive scheduling. It is follows and always runs the highest priority task that is ready. That is the first priority is given to the higher priority. Under this circumstance, if n is the number of tasks and ei is the execution time of a task I, and ti is the period of a task I, then the deadline to meet if the following inequality is satisfied by the execution time of a task I, the summation of all the execution tasks divided by the task period should be less than equal to number of tasks where in bracket 2 to the power of 1 upon number of a task minus 1. That is how the task scheduling is being defined. Now coming to the memory management, you can see that the service of a memory management is to include what the initializations of the memory manager, the one, and then the next is the creation of a memory partitions. That is the in the case of a memory management, and you can do a memory partitioning for obtaining that particular status. You can create a memory block, and not only that one, you can return to that memory block, waiting for a memory block from the memory attritions. So that's how the memory management, the complete memory management can, under the case of a MicroC, can you can see that initialization, creations, status creations, and block creations, as well as waiting in case of memory attritions. So this is what seen in the memory management. So here I have put across some of the reference with respect to this particular entire discussion on operating systems, real-time operating systems, VxWork RTOS, and MicroC OS discussions. So one is with respect to the Raj Kamal publication, another is with respect to the tutorials from the Adrian Gambier. So I believe that this information was sufficient to understand the concept. Thank you.